Welcome. Today, we're going to talk about a force so powerful, it shapes every single line of code you will ever write. And no, I'm not talking about the latest JavaScript framework or some passing trend. We are talking about an unbreakable law, something that will stick with you for your entire career in software. So let's just start with a question that I think every single developer faces, probably sooner than they'd like. Why is it that today's amazing, shiny, best practice somehow always becomes tomorrow's big, ugly legacy problem?
Well, to answer that, we have to dig deeper than just trends. We're on the hunt for something fundamental, a real law of software architecture, something that's going to hold true for a 40-year career, not just a 4-year project cycle.
Think about it like this. In physics, you have laws like Newton's law of gravitation. It's so robust that even when Einstein came along with relativity, Newton's original law was still incredibly useful. It wasn't wrong, it was just incomplete. So the big question is, does software have anything that's solid? Let's find out. Okay, so before we get to the main event, our big law, let's look at a couple of other concepts in software that really hint at these fundamental limits. Think of these as the hard walls you're going to hit in your career again and again. So you've probably heard of these two famous laws in software, Amdahl's law and Brooks's law. Now, they both reveal this really crucial concept, the asymptote. You might remember that from math class, right? It's that line a curve gets closer and closer to, but never actually touches. Well, in software, it's a hard limit you can't overcome, no matter how many resources you throw at the problem.
For performance, that limit is the single-threaded part of your code. You just can't make it go faster with more cores. And for productivity, the limit is the cost of just human coordination. Adding more people eventually makes things slower. These are the walls you will absolutely hit.
So this begs the question, is there a similar asymptote for software architecture itself? Well, to find out, we need to go back, way back, to a really remarkable paper from 1968. The paper was called How Do Committees Invent? And it was written by a computer scientist named Melvin Conway. Fun fact, it was actually rejected by the Harvard Business Review, but it ended up changing how we look at software forever. Conway's central observation became what we now know as Conway's law. And it's simple but profound. Your org chart dictates your architecture. The way your teams are structured literally forces the software to take on that exact same structure. Let's see how this actually plays out. Say you create a new media division. Okay, great. Then you split it into an audio team and a video team. All of a sudden, it's way harder for the audio folks to talk to the video folks. And what do you get? You guessed it, separate audio and video APIs. The software becomes a perfect mirror of the human structure that built it. So there it is. The org chart is the architectural asymptote. The absolute best design a team can produce is one that simply reflects its own communication structure. But what happens when you add time into the mix? This is where things get really interesting, and where we see a kind of refinement to Conway's law. You see, modern software isn't built from scratch anymore. It has a long, long history. I mean, think about a massive code base like Windows. It's been around for nearly 4 decades. Conway was thinking about one org chart making one product. He never really foresaw that the product itself would outlive that original org chart by decades. And the result is kind of terrifying. Your software becomes a superposition of every single team structure that has ever existed at your company. Let's look at a perfect and, frankly, completely absurd example of this in action. How many volume sliders should an operating system have? You'd think 1, right? One audio team makes one master volume control. Simple, clean, good design, done. Okay, maybe 2. Conway's law totally predicts this. You have the OS company's audio team, and then you have the hardware vendor's audio team. They're in different companies, they don't talk much, so boom, you get 2 sliders. That makes a certain kind of sense. But in modern Windows, you can find 5, seriously, 5 different volume sliders. And this isn't just a series of bad UI decisions. No, what you're looking at here are the ghosts of org charts past. Each one of these sliders corresponds to a different team from a different era. You've got the Windows 7 teams work, the Windows 8 modern UI teams work, the Windows 10 teams work. Their code was never fully replaced. You are literally seeing the history of the company's reorgs right there on your screen, and that is Conway's nightmare. But hold on, the nightmare gets even worse. Because the org charts aren't just a management problem anymore. We, the developers, are putting them directly into our code.
Take a look at this class diagram from a real-world compiler. We create these deep, really rigid inheritance hierarchies to manage complexity. And as students, you're often taught this is good, clean, object-oriented design.
But watch this. If we just turn it on its side, whoa, it's an org chart, isn't it? We are creating these rigid communication boundaries inside the code itself, not for any technical reason, but just because the problem is too complex for one person to hold in their head.
And our modern development practices are just doubling down on this. Microservices, package managers, containers. These are all fantastic tools, but they're also tools for creating more boundaries, more walls that prevent holistic global optimization of the system. So what's the takeaway here? I mean, what can we actually do when we're faced with this unbreakable law? Melvin Conway told us the answer all the way back in 1968. We have to design for flexibility. We have to see these boundaries, both in our teams and in our code, as necessary evils that we should always try to minimize, not as virtues to be celebrated.
And this is really the final, crucial question you have to ask yourself on every single project you work on. Are you building the best possible solution for the problem? Or are you just shipping the org chart again?